So whenever we have quadratics, and if we're expected to graph them, they're going to be in one of two forms. The first form they're going to be in is standard form. The second form they can be in is vertex form, which vertex form is exactly what it sounds like. It's a form where you can see the vertex. You don't have to calculate it. Now, we don't need our computers today, so go ahead and close those and put them away, please. All the way away, not just closed off your desk. So we're going to start with writing out what is vertex form of a quadratic, okay? Extra conversations need to go ahead and stop, okay? So for vertex form of a quadratic, can you close your computer, please? Okay, we have y is equal to a times x minus h squared plus k. Now, this might seem a little weird, but if I was to take and actually do x minus h times x minus h, multiply the whole thing out, combine all my like terms, do all the things, I would end up with it in standard form. It would end up in ax squared plus bx plus c. That's how it would end up. Okay, this is just another way it's sometimes written. And you might recognize this form, okay, because this is very similar. What did we use h and k for? Transformations. We've used them several times now, okay? So all we have to do when it is in vertex form is identify our transformations, use those transformations to write our vertex, okay? That's all we have to do. Now, just like with standard form, A tells us if it opens up or opens down, right? So if A is positive, it's going to open up. A is negative, open down. Yes? Go ahead. All right, so when we look at this, we can find our vertex just by looking at the point H, K. We can also find our axis of symmetry by just looking at what our H is. Now, when we do this, it is dependent on which direction it's moving, okay? So if it goes to the right 5, would to the right be a positive or a negative number? Positive, okay? Now, that's a little weird, though, because what does negative h tell us the direction is moving? Tells us it's moving right, okay? But when we write that as a point, since it's going to the right, we would use a positive number. It's very weird, and it looks backwards than what it is, right? It's the same way it's been the entire year, though. So if we have positive h, which way does that move? Left. What about positive k? How does that move? What was that? It goes up. Negative k is going to move it down. And then if we were to make a negative, what is the math word for what it causes to happen when it flips the other way? Starts with an R. Reflection. It gets reflected. Okay? And if you want to make a little note there that if A is positive, it opens up. But if A is negative, it opens down. If you want to make a little note that says that on there, that might be helpful for you. Okay? So that's what we're going to start with. And we're just going to identify our axis of symmetry and our vertex. Okay? So let's go ahead and look at number 1. So when we look at number 1, we have a few things happening. Inside of our function there, we have plus 4. Okay, how does that make our graph move? That moves it to the left 4. Okay, since it is going to the left 4, what does that cause our axis of symmetry to do? So let's think. If that's our graph and we go to the left 1, 2, 3, 4, it would be a negative 4. And that's also the x-coordinate of our vertex. Okay, then we have that minus 2 at the end. What does that cause to happen? Down 2. And if I have my graph and then I go down 1, 2, is that going to be positive or negative down there? Negative 2. So that is my axis of symmetry in vertex. That's all I have to do to identify it. Now, in the very, very front of this, it's understood to have a 1 right there. So does that mean it's going to open up or down? It's going to open up. And we're going to do the same thing for number 2. For number 2, okay, in the very, very front, we have this negative. Okay, that's technically -1. So what does that cause our graph to happen? To reflect, which is going to make it open which way? Down. So that is a reflection that makes it open down. It would look like that. Now, what does that -3 right there cause to happen? To the right 3. And it would be a +3. So x is equal to 3, and that is also going to be the x coordinate of our vertex. Now, if we go ahead and we look at this, does it have a k being added at the end? That is like it has +0 right there. So what is the x or the y coordinate of our vertex? 0. Because there's not a vertical shift happening. It's not going up or down any, so it's just 0. Now we're going to look at number 4. So number 4 is a little weird. It looks more similar to standard form than vertex form, okay? But that is just because it's missing which term of standard form? It's missing the B term, right? So if it misses the B term, automatically that tells us our axis of symmetry is going to be 0. So I want to talk about why that happens. So we actually have here y is equal to -2 times x plus 0 squared plus 3. That is technically what that is, because there is nothing being added in there with the x. So if I go to look at this, the very, very front, what does that negative in the front cause to happen? Reflection, which makes it open. Now, is there any left or right shift? No. So what is the x coordinate going to be? What is our axis of symmetry? 0. And that is also why if you have it written like this in standard form and there's not a b, that's why it's 0. Because there's no term there that's being added, okay?
Do we have to change it still, or is it?
You don't have to rewrite it from this to this. I just want us to understand what's happening in there, okay? Then we do have this +3 at the end. How does that +3 cause our graph to move? That causes it to go up 3. So how does that affect our y coordinate? It would be +3. So that's our vertex. So I want y'all to go ahead and try to do number 3 for me. What is our axis of symmetry in number 3? It is x equals 5. What's our vertex? 5, -4. Okay, because this -5 inside our function here that's being squared, that causes it to go right 5, which is +5. Then we have our -4, which causes it to go down 4. Okay, that is all vertex form wants us to do. Okay, vertex form just gives us a different way of finding our vertex and axis of symmetry. Instead of having to calculate it, it pretty much gives it to us as long as we can recognize our transformations. The graphing half of it is the exact same. Okay, so let's go ahead and we're going to do some of these. Okay, so I want us to go ahead and look at number 5. When we look at number 5, okay, we start, it has this minus sign in front. What does that minus sign cause to happen again? Reflection, which causes it to open which way? Makes it open down. All right. What about that plus 2 inside the function? How does that affect it?
It makes it go to the left.
To the left too. So what does that make our axis of symmetry?
A negative.
And then what does that make the x-coordinate of our vertex? -2. Yeah, still in the x-coordinate. We haven't switched yet. Then outside of the function, we're adding 7. What does that cause to happen? Up 7. If we go up 7, it's going to be at the point -2, comma, +7. Now, just like with standard form, once we get here, we just take our vertex, put it in the middle, -2, 7, and do points on both sides of it. What's a number that's smaller than -2? What's number smaller than -3? What's bigger than -2? Bigger than -1? Okay, so those are the numbers we're looking at. Then we grab our calculator and we do the exact same thing. Okay, we hit y equals. When we type this in, we type it in just like it appears, parentheses and all. Okay, so negative, parentheses, x plus 2, close your parentheses, square, plus 7. And then second graph, and it gives us our table. If y'all hear my belly growl, I'm so sorry. I promise I ate breakfast this morning. When we plug that into our calculator, what do we get for our y value when x is -4? Three. What do we get for our y value when x is -3? What about when x is -1? 6. Because remember, it's symmetric, so those two have to be the same. Okay? When our y value, or when our x value is 0, what is our y value? 3. Again, it has to be the same as that one because they are symmetric. Now let's go ahead and graph. When we graph, we do put our axis of symmetry on here as a dashed vertical line. We do a dashed line because that line doesn't actually appear in the graph, but it breaks our graph into half, and it's good to have, okay? Helps us to make our graphing go a little bit smoother. And then we're going to do -4, 3, 0, 3, -3, 6. And I plotted all of my points. Now we can draw in our curve. All right. What is the domain of this? -infinity to +infinity. What's our range? What is the lowest point of this graph? What's the highest point?
7.
So it goes from -infinity to 7. All right, for number 6, let's go ahead and look at this. So is our number in the very, very front positive or negative? Positive, so it's going to make it open up or down? Up. Now, real fast, does anybody remember what happens to our problem if we multiply it by 3 in the front? What does it cause our graph to do? What would happen if I multiplied your height by 3? What would happen to you? You would get stretched. So that is a vertical stretch. When a is bigger than 1, it's a vertical stretch. Okay, what happens with that minus, but does that vertical stretch affect our axis of symmetry or our vertex? No. Okay. What about that -1? What does that cause to happen? It's inside the function. It's inside our parentheses, so that makes it go right 1. If it goes right 1, what does that make our axis of symmetry? 1. And that's also the x-coordinate of our vertex. Okay, does this have anything added or subtracted at the end of it? Does this have a k? No. It's just like saying plus 0 right there. So what's the y coordinate of our vertex? 0. So that is what we put in the center of our table. So I want y'all to go ahead, use your graphing calculator to find the rest of the table and graph it for me, okay? And I'll let y'all check y'all's answer in just a second.
Whenever the number's bigger than 1, like this stretch.
Mm-hmm. What is the y value when x is negative 1? 12. Does 12 fit on our graph? No. Okay. It is okay if one of the points goes off the graph. What matters is that you have your vertex and 1 point on each side of the vertex to graph. And do we still have that? We do. Because we should have, this is our table. So I want y'all to finish graphing now. And if we look at that graph, it did get really stretched out, right? It got really tall and skinny real fast. What is our domain? Negative infinity to positive infinity. Have y'all noticed something about our domains? They have all been negative infinity to positive infinity. That is a property of quadratic equations, okay? Unless specified otherwise, unless it tells you the domain has been restricted, the domain is all real numbers because you can plug anything in to square it. I can say negative 5,280 squared, positive 92 billion squared. Okay, 0.000000002 squared. All of those things are things I can square, right? You can plug in any number, which is why it is from negative infinity to positive infinity, because it's all real numbers. What is our range for that, though? 0 to infinity. Because the lowest point is at 0, and it goes up forever. Okay, we're actually going to skip the back of this page. Okay, we're going to put skip, and we're going to move on, okay? And we're going to kind of go to the put it together section. So when we look at this section, it's kind of just us reformalizing all of our transformations yet again, okay? So it says, given a quadratic in vertex form, which is y equals a times x minus h squared plus k. So when we look at this, our h, whatever that h is, that determines our horizontal shift. If it's positive, it shifts left. If it's negative, it shifts right. The k term, that is our vertical shift. If it's plus, it goes up. Negative, it goes down. The rest of the transformations have to do with that a term, or what's in the very, very front. So if a is negative, we already said that it gets, what was the math word for that? Reflected. It specifically gets reflected across the x-axis. That's what makes it open down versus open up, okay? And if our absolute value of a, so what the actual number is if the number is bigger than 1, it's a vertical stretch. It's going to make your graph get tall and skinny really fast. It's like taking your height and multiplying it by 3. If we have the absolute value of a between 0 and 1, so that's your fractions, 1/2, 3/5, 6/7, 2/3, all of those things, okay? If it is that is what is causing our graph to shrink. or compress. It is a vertical shrink or compression. You can use either word. And that makes our graph get wider and flatter, okay? It doesn't get tall as quickly, is essentially what's happening. If you become half as tall, you would get smushed, right? Okay, now, we're going to go ahead and we're going to do the 2 questions at the top of this and just make sure we've got it, all of our transformations down. Okay, so let's look at number 11. This does already have the graph here. That's just the plain old graph of x squared, okay? It's there so we can see our transformations a little bit. So if we look at number 11, that is the same as if we had y equals 3 times x plus 0 squared minus 7. That is the same thing. So if I look at this, it also asks me to do my transformations. What does that 3 at the very front cause to happen as far as transformations go? Vertical stretch by 3. Now, what is about that plus 0 in there? Does that affect anything? Does that cause anything to happen? No. What does that make our axis of symmetry, though? X equals 0. Okay, and it also makes our vertex x coordinate what? 0. Okay, what about the minus 7? That is a transformation of going down 7. And what does that make the y coordinate of our vertex? Negative 7. And so that is what we put in the middle of our table. 0, negative 7. And go ahead, and I want y'all to graph and finish that table.
So whenever it doesn't have a reflection, do you still want us to write open up?
Some questions will ask you to circle whether it opens up or down. So it'll just depend on that. That's why I've had us doing it, just so we don't get out of habit of doing that. So if you graph that, you can very clearly see that it's getting stretched out, right? We can see that the graph moved down. So to go from this graph to the blue one, it had to move down, and then it got stretched out, right? Whenever we look at them, that's what's happening. It is how this graph of x squared right there is changing. I want y'all to also do number 12. Let's do the transformations of number 12 together, though. So for number 12, what does that minus in the front cause to happen? It is a reflection, okay? Specifically in the terms of a quadratic, what does it cause to happen? It causes the quadratic to open down. So that one will open down. What about the 1/2? What does that cause? Is that greater than 1 or between 0 and 1? It's between 0 and 1, so that makes it a shrink. What about the -3 inside the function? How does that affect it? right 3. Okay, what about minus 2 outside the function? Down 2. So what is the axis of symmetry going to be? X equals what? 3. And then our vertex x coordinate is going to be, then our y coordinate is negative 2. Okay, that is what goes in the center of our table. So I want y'all to finish graphing it from there. When you type it into the calculator, type it in just like it appears, fraction and all. And that is what we should get for that. So what I want us to do is I want you to spend the rest of class finishing any parts of the pink packet from pages 1 to 4 that you haven't already. We're going to finish this sheet tomorrow, do some practice, and possibly go ahead and start on our review.